So I'm Andre. I'm from Fitbit Engineering. I'm here together with my colleague Alex, but I'll let him introduce himself when he starts his part of the presentation. I don't really think you can get to know somebody with three simple questions, but still, can we get a show of hands just so I understand and we try to make this presentation as interesting as possible for everybody? Who here in the room is on the technical side of things, so developers or engineers? All right, cool. And who's on the product side or product development or business development? Awesome. And finally, how many of you are working on a startup of your own as opposed to, like a more established company? All right, cool. Cool. So we're going to talk about the changes that we're currently doing at Fitbit, so we can get in a word features to our customers in a more reliable fashion, developed faster, easier to be tested, so we can easily gauge out whether they're effective or not, and the way we're doing that in our current ecosystem, what we're changing inside of it, and what the future looks like. So we're going to talk about mainly three things. Kind of like the current state of the Fitbit architecture. Each company has its unique challenges and idiosyncrasies, if you will. Fitbit is no different, but we're doing some changes in order to, like I said, be able to move faster and better. We're going to talk about moving to the cloud, and this might be interesting to some of you who are currently running in a more shared environment or like hosting-like environment, and if you're planning to move to the cloud, that is if you're not already there. And finally, we're going to talk about how we see the future of application development inside the Fitbit ecosystem. And that's our developer platform. So, the presentation was entitled, building experiences across three screens, right? But there's only two here. Semi-clickbaity, I'll admit. But one of the screens, so what are the two visible screens at first, right? So apps and devices. This is like if you ask somebody or if you ask anybody at Fitbit, how do we make money? This is how we make money. We sell devices together with an integrated app. The device has a bunch of sensors on it, heart tracker, sleep tracker, all kinds of things to make you more healthy. We've got the application where we build out new tiles so we can give you more metrics to let you basically be able to know a lot about stuff about your health and your well-being and the way you're how fit you are basically. So how do we make more money, right? So we've got, state A, how do we get to state B? It's pretty simple, right? So for devices, we can do better design. We have a great, design team that can, we change the design, we change the hardware, we implement better features, better sensors, pretty straightforward. Same thing for the applications. We experiment with new tiles, new metrics for the user. It's pretty straightforward feature development, right? But there's also an invisible screen, right? Which is the cloud or the backend part. It's invisible in most cases. Nobody cares about it. It's only visible in a single situation, when it doesn't work anymore, when it crashes. In our current architecture, this is the most, most important part. Basically, the core of so what's happening, right? When you have your device and your mobile and your connected mobile Fitbit application, what happens to your data? It gets collected from the device, or from the tracker, or from the scale, or from the smartwatch, and then we actually use the mobile device as a way to, as a trampoline to push that data to the cloud, where we store and we collect everything about our users. This is not, by the way, I'll make a parenthesis right now. The way we store data for our users is totally encrypted and private. We're not in the business of, selling our users' data. I mean, it's totally different than other companies. What we want to do is keep it all into one place, so we can basically make it. We basically know a lot about you, so we can detect whether you're feeling well or you're feeling bad, and what's going on there. So it's pretty simple. It's a kind of straightforward architecture. We collect it, we push it over the internet inside our Fitbit network or our backend application, and we store everything there. The core of this process, we call it sync, right? From synchronization. And basically, Sync gets the data from your device and puts it in the cloud. And like I said, nobody really cares about this process except when it crashes. So what happens in the backend? For Fitbit, everything happens in the backend. That's why we say it's the single most important part. Just to give a couple of examples, we have some social features like challenges where you can challenge your friends or do some step challenge or a fitness challenge. Of course, to be able to get and measure across a set of users, we've got to get the data in a centralized place. So that happens on the back end. When we calculate how deep or how well you sleep, the feature that we call sleep tracking, using machine learning and other algorithms, all of that is happening on the back end. It's not happening on the device. It's not happening on mobile phone. So, okay, so we're right here. We have a pretty established way of developing and deploying applications. This is our current architecture. The thing you'll notice about the current architecture of Fitbit, it is a bit heterogeneous at the moment. We've grown it, quasi-organically. We did some changes in order to ensure that our users are well served by this. But basically, what happens, inside our backend or inside our cluster infrastructure is we basically have two big parts. We still have a non-containerized architecture with a bunch of applications and a monolithic application which does a lot of things. But like half or more of our applications are actually containerized, and we're deploying on a Mesos and Aurora cluster containerizer, so we can do scheduling of containers across a cluster. And of course, we also have separate data storage. We have those services separate. They're not containerized because typically containers aren't really good at this. Both Mesos and Kubernetes are just coming up with ways of being able to serve data storing workloads, so those are kept separate. And of course, we also have data processing facilities, and like you've seen maybe in previous talks or the talk this morning, those are kept separate. And the reason why we have that is because we can't have offline batch processing workloads interfere with the hot path of the data. So the way you do batch processing, and this is an architecture that's not new necessarily, but it's the way you have to do it is you do it on demand. When you need to do some processing on the data, you copy it to a different cluster, so you never impact the production traffic. And this is how the architecture looks like in the cloud. So this is pretty public news. Fitbit announced somewhere last year that we're in a strategic partnership with Google. So we're moving, our platform on top of their cloud, on top of their cloud services. Of course, it's a much more homogeneous infrastructure. Everything is containerized. We get, all the data processing workloads we can do using the same infrastructure. The only thing that it's still kept separate, but even there, who knows? Maybe in the future, if we get higher level offerings from GCP, we'll be able to take advantage of them. Again, data storage is something that's kept separate because, as you'll see in the future slides, it's something that is super critical to us. So what did we get right and wrong when moving this whole behemoth to the cloud? So we did some preparation, and we were kind of in a good state because we did some things ahead of time. One of them was containerized workloads. And for whoever here is running workloads that are not containerized, just please move to containers. So by the way, I keep saying containers, but I'm not saying Docker. We actually think that Docker is an implementation detail. We think there's a lot of other containerizers which can do the same thing. For us, containers are a way of completely bypassing the configuration management and dependency management problem. We're not using any kind of higher level functions. We actually do think that the scheduling and the containerizing should be kept separate from an architecture point of view. So that's what we mean when we say containerizers. But containerized workloads, basically what containers give you the way, you don't care anymore where the stuff is running. The same container can run everywhere, right? That's the most important thing here. So that was pretty good. The other thing that was good, and we actually have a super good story at Fitbit, is unified monitoring infrastructure. So if you think about it, you might say, yeah, well, you kind of a mono application. It's just the Fitbit application. Yeah, but there's a bunch of stuff that happens that's going on behind the scenes inside this application, and there's a lot of subsystems, and they are all pushing logging, metrics, telemetry data to the same place. So we have all of our monitoring data in the same place, and that's been super helpful and instrumental in being able to know what our system is doing as we perform this migration. The third point is we had, and we changed the organization a little bit actually, to be able to do this move. So what we, if you know about, there was the D-Day anniversary a couple of days ago. We actually had like a team, we called it Bridgehead, which they kind of basically started working on the GCP stuff 6 months, 1 year to 6 months before the rest of the company. So when the rest of the company started the move, we already knew what was working, what was not working, all the little gotchas that you get in any cloud providers, not only Google, be it Azure or AWS. And there were a couple of things which weren't so great because not everything is going smoothly all the time. Some part of the application, of the Fitbit application, is still monolithic, which means you have to move it all at once. And when you have to move everything at once, you get a lot less confidence that stuff is not going to break. And there's a lot more work that you have to do beforehand to be able to do two things. One is to know when stuff is going wrong. Second, if stuff is going wrong, being able to quickly revert it or roll it forward. And yeah, that was pretty painful. Also bad was the fact that we did have a couple of workloads which are super latency dependent. And latency is something that a lot of engineers kind of ignore until you're in an environment where latency is always there. It's measurable. It's not the same, so it's variable. When you get into this kind of like perfect storm environment where latency is super variable and it's always non-zero, that's when you start finding out a lot of the leaking things inside your application or inside your system. Keep in mind that latency also refers to connection latency, basically, right? But in some pathological cases, depending on the systems and depending the way the systems talk to each other, you might see cases where latency gets multiplied, right? Because connections get multiplied. You might have places in your system where they do 5 connections in a row when you can only have done 1. And you don't even know it until you get to this and you see in a variable latency environment. So what was by far the biggest difficulty? So this was the biggest difficulty. This is a graph from our monitoring infrastructure. Some things have been blurred out to protect the innocents. But basically, if you look on the left-hand side, that says billions. Fitbit has tens of millions of active users, and it has billions of requests each day, every day. At any point during our move to the cloud, this graph has to, well, it kind of moves, but it shouldn't move erratically. Basically, our users shouldn't have to feel anything while we do this move. It's a super old metaphor with, changing the engine in the car while it's still running, so I won't repeat it, although I just did repeat it. But anyway. That's kind of the biggest difficulty by far. So every time and every decision that we do related to this move, it has to take this into account. And always the question is in the back of our minds: will this affect uptime? Will this affect latency? Will this affect the experience that our users have? So what do you do? Like, how do you actually move this entire thing to the cloud? So the framework we've developed, or the order of operations, if you will, that we chose to do, is basically this. First off, we know that we use a containerized workload, so we need to have basically the same infrastructure in Google Cloud Platform, right? So that means setting up everything that we need there. We need to set up databases, we need to set up Mesos and Aurora, we need to set up the monitoring infrastructure. We need to set up authentication and authorization control so that service teams, don't step on each other's toes. We need to set up networking. You can set everything up, but if nobody knows how to use it, then it's useless. So you need to write documentation on top of this. Then we start moving the internal services, right? Stuff that we don't care that much if it breaks. If it breaks, sure, we'll take a learning and then we'll incorporate it in the next step. So, steps 2 and 3 are basically like a feedback loop where we move things, see what breaks, take the learnings back, and then, for the next move, that will not happen again. Third is we move the new features. Those things are already containerized, they're out of the monolith, they're great, they're, shiny, so we can just take those things and move them and be pretty sure that they will work. Finally, we set up the data migration plan. That is by far one of the hardest things to do, and there isn't a lot more to be said here because this is super dependent on what your company does, on what your data layout looks like. Like literally, data layout is probably a whole presentation of its own. So for us, that means basically how do we move users' data so that a connected user to the application never feels that the data has been moved behind the scenes. There's a lot of literature about this. It still doesn't make it easy. So moving the data, that is the hardest part, because if an application is down, yeah, we look bad. But if we lose the user's data, then that is super bad. And finally, we kind of move everything else. By this point, we have a data migration plan, so the user's data is safe in the new place. We know how to move containerized features. We have all the infrastructure, so we just move everything else, and we're pretty confident that it's going to work. Why are we doing all this, and what does that have to do to building experiences for our users? So what's the deal? Why are we doing this? So again, what's the value that we bring to customers, right? We talked about earlier, we sell devices, we have an application, we give you information about your health. So it's devices, it's experiences, but all of those things are built on top of data. What we want to do is increase the speed of development. Again, you've heard this term, especially if you're doing business development or product development. This thing, speed of development, experimentation culture, testing culture. How do we test? How do we do A/B testing, multivariate testing? How do we make sure that when we invest money in a feature, it's going to bring that money back to us? How do we know whether or not it's useful, right? So this is why we're doing this. We are not an infrastructure company. This is not our core competence. Our core competence is, making you a fitter person. So we need a way, and we need the setup that we use, the systems and the infrastructure to be set up in a way that gets us to this place faster, so we can move faster. That's the main reason why we're moving to the cloud. Also related to speed of development is self-service operations. We want development teams inside Fitbit to not rely on emails or Jira tickets or anything else to be able to develop and deploy their applications. They should be able to do everything themselves. They have the tooling, they have automation built on top of this to be able to deploy and get feature from somebody's IDE into a public endpoint. They should be able to do that on their own. And finally, it's also a question of cost. Fitbit, like I said, is operating on a massive scale. We have tens of millions of connected users, so cost is something that's always important. And cost comes into play, like I said, when you realize that we are not an infrastructure company. We're not in this business to run our own data centers, basically, right? So we should let somebody who does it better do it for us. So again, So we're selling devices. A lot of other companies sell devices. We make apps. A lot of other companies make apps. The only unfair or unique advantage that Fitbit has is data. We have years worth of our users' data, data which is protected and encrypted. We have super safe controls around the way this data is stored. So then, the only question that remains for us is how do we build experiences on top of this data for our customers faster? And I'm going to invite Alex up to talk about the Fitbit Developer Platform.
Hello, everyone. I'm Alex, and I work on the developer platform team. Although this is going to focus mostly on the smartwatch app ecosystem, these principles kind of apply to all our efforts to orchestrate support for feature development. So this also kind of appeals to things like services that kind of interact directly to the user. We are kind of a part of a very unique team because the skill sets required in my team are very diverse. So if I were to read a CV, a job description, it would be you have to know, among others, JavaScript and C, which I'm sure that a lot of people don't have as a competency. Not necessarily that we have, but we have to do it. Right, so let's move into it. So how does an app actually look, a smartwatch app look? So we have some code running on the device. We also have some code running on the mobile. The code running on the device makes sense, right? Because you have an app that runs on a device, on a smartwatch. But what's with the code running on the mobile part? So let's go through them. The first thing is the settings view, which is kind of self-explanatory. It's a view that helps you customize a lot of the experience because the smartwatch is not a great medium to introduce data. So you can have things like color pickers, you can have things like string inputs, you can have things like login information. One example is the Strava application, which for which you actually have to go to the settings page, log in, so you can use your Fitbit data and log it into Strava. The other part is the companion part, which I usually describe it as a proxy to the rest of the world. Although we have a lot of data on the smartwatch, like sensor data or service data, and by service I mean exercise, we don't have any connection to the rest of the world. So the companion is the proxy to the world. It lets you create requests to other services, Fitbits or otherwise, or other. And also it lets you crunch a lot of data. So I think that, sorry, I kind of lost my trail of thought. So that's kind of the reason we have the companion for. But why don't we make requests from the smartwatch? Because we do have Wi-Fi on some devices. Well, the problem with the device is that it has very limited resources. So it has low memory, and it has a small, slower CPU than other smartwatches. This might come across as being cost reduction, but it actually is not. We pride ourselves in delivering a great battery life for our experiences, so that helps us deliver it. So, and another thing why we don't make requests from the smartwatch is because we also have a lot of, as I mentioned, the small memory footprint. We have a lot of a very small memory allocated to apps running. So we have around 64 kilobytes for each application that runs, which is fairly low. And when you take into account that that doesn't include the code loaded into memory, that gets even smaller. So imagine making a request from the smartwatch where the payload is around 100 kilobytes. That would basically crash your app. Sorry. So this is another reason why we went with this pattern. But why JavaScript, right? Because, I mean, taking into account if we have so few memory allocated, why use JavaScript? Why not use something like C? And this kind of boils down to the fact that we need to have something that runs cross-device in terms of mobile. So we need something that runs both on Android and on iOS. And the only language that kind of works and can be loaded dynamically is JavaScript. There are some things that we can do for Android, but that even if iOS supported the same things that we can load dynamic code, it would still require us to have two different companions work on our device or in our application. Okay, so why, coming back to the point about why JavaScript, we also feel like JavaScript is a very good entry point in terms of, let's say, it has a lower barrier point than C, for example. You won't see designers come up and start writing code in C because it's much more difficult to start on. So this is another reason why we kind of have JavaScript on the device. Another reason we have JavaScript is the fact that we can sandbox very easily, basically free, let's say free, the code. So we don't have to manage a lot of resource access that might happen in a way that we don't desire it. So regarding JavaScript, how do we run JavaScript on such a low memory footprint? We're using a JavaScript engine named JerryScript, which is developed by Samsung, which, ironically or not, is our competitor in some markets, but is also supported by ARM and Intel. It runs in around 64 kilobytes, which is extremely low, and also on disk it kind of takes 200 kilobytes, which is incredible. And this taking into account that it delivers a JavaScript implementation which is ECMAScript 5.1 compliant, which is extraordinary. Plus that, on top of that, it also provides promises, which is extraordinary. So how do we communicate between the application and the companion part? So we have two ways of doing that. It's either via file transfer or via sockets. What's the difference? So sockets are kind of unreliable because the design implementation is fire and forget. So you don't have any guarantee that the messages actually reach the destination. File transfers, on the other hand, function offline as well. So you don't need the application to be running. And also, it has an acknowledgement on its part. So when you send a file, it actually, we await an acknowledgement, and after the acknowledgement comes, we remove it from the cache. So from the files that need to be sent. Right. Okay. Okay. So this is kind of an overview of how FDP actually looks. So we have two ways of shipping code to the smartwatch. We have the developer relay, which is the normal development process, and we also have the App Store way. So the App Store ways, the App Store way kind of is similar to what you'd expect from an App Store. You submit an app for review, it goes through review, and it has some standards for which it has to comply. Also, there are requirements like permissions that need to be granted by the user, which might break or make your application. The developer relay process, which is the development process, is basically our pipeline and how we can fast iterate and develop applications. It doesn't go. It has nothing to do with the store way of delivering the data. It's basically on its own, and it has a special implementation on the watch. On the bottom, in the yellow block, we have Bison, and Bison is the code name we gave to Fitbit OS, which is a combination. And actually, the code base is firmware Bison, but the Bison platform incorporates both the code base and multiple hardware platforms. So you have the hardware platform for Versa, for Ionic, and Versa Lite. And for each implementation, we also have a lot of different providers for the same component. We want to do that, to have multiple providers, because first of all, it's a good way to push other people to lower their prices, because you have competition. And the second reason is you always want to have a backup. In the past, we kind of were bitten by the fact that some providers changed their plans, and we had to readjust. Right, and that's kind of the OS part. And how does an app work? So an app interacts with the layer we call Rocky.js, named after the movie character. I wasn't there when it was named, but it probably had a reason. It's platform agnostic, and if tomorrow we decided we want to get rid of Bison because we might iterate on the platform, Rocky.js will still be there and still work, and will provide a consistent experience and help us provide the same SDKs that we want to. The custom part is Rocky Port, which is a very platform-dependent component, and that's the middle tier between Rocky.js and the platform. And that's very custom to what the system design is for the smartwatch. Right. Let me see. Hopefully, I didn't forget anything. No. Looks good. This stopped working. Huh? I don't know where my. Oh, right. Okay. So, what do we provide to facilitate all the app development? So we have a SDK toolchain, which is an NPM package, which does a lot of things for us. It's open source, by the way. It's written on the last point. So what it does, it provides us a way to validate, to transpile our code if you wrote it in a TypeScript. It minifies our code, so it actually eats less memory when application is launched. It also does something like resource filtering, which is a feature that allows you to define resources specific to a platform. So, for example, you might have an image named image.png, but you might also have something like image-300 x300.png, and the SDK toolchain will grab it, strip out the resolution, and only apply it to the devices with that specific resolution. We also have a thing like that. We also have a thing that converts your file formats from PNG or JPEG to a proprietary format that actually can run on watches. So we use a format named TXI, and that's the only type of image format that we support. Other things that, we also kind of validate configuration. So when you have things like app ID that needs to be in a specific format, when you have type of devices, when you have a lot of other options, we also validated that works before you actually ship it to the store and get a reject from there. That doesn't work. Another way we kind of used the SDK toolchain was to provide fixes for firmware software that was already shipped. So one example is when we shipped Versa Lite. Versa Lite has fewer sensors than the other devices. So we actually came, and in the SDK toolchain, we added some things to make your application still work till we got the firmware change in. So the way we kind of define our APIs, we always kind of try to appeal to the public standard for those APIs. So, for example, file system is basically copy pasted from the Node.js repo, in a sense only by typing, right? Because it's proprietary to the OS. And there are other things like, for example, set timeout. Set timeout, for example, on both the watch and the Android part don't exist. It doesn't exist on Android because it runs in a web view, a headless web view, so we have to define it. And it also doesn't exist on the watch because it's not a part of the ECMAScript 5.1 implementation. So other things that we have are that we kind of define is the dev bridge, which is basically the mechanism in which you can connect to your dev relay services, and you can deploy code, and you can install application, you can take screenshots, and a lot of things when you're developing. So that's really helpful. We also provide the CLI tools, which are basically an implementation over the dev bridge, which is the specification. This gets really hairy, so I'm trying to sum it up. So that's implementation of the dev bridge, and that also kind of takes into account the services and how we can reach our services. And as mentioned, all the tools are public on GitHub. We take contributions. We actually have received a lot of them. So if you're interested, please go ahead and check them out. Okay, some other tools or things that we provide to help developers in need. So we provide something named Fitbit Studio, which is an online IDE, which is perfect for people who don't know what Node.js is or NPM or CLI. And that's basically, that also wraps around our SDK toolchain, which is incredible if you think about it, because you have an API that is defined to work on Node, and also it can work on the cloud. And the way we do that, we do some ugly stuff like implement a virtual file system in the browser so you can actually build and store apps in a zip file, for example. Interesting thing is that when we're building, as I mentioned, in the browser. So we're not shipping the code in a service and building for you. The Fitbit developer platform was actually started by the team at Pebble. So they were acquired in, I think, December 2016. And by September 2017, they had all the stuff. And believe me, it's a lot. So they had a previous issue where they would just build code in their machines, and they had like a leak. They had a symlink exposed, and the code that was from outside could exploit that. And that was a reason why they said, we're just going to build in the browser. Apart from that, we also provide a simulator. And again, it's a simulator. It's not an emulator, which means that a lot of the base structure is re-implemented and different from the OS part. And it's an Electron app, and that lets us ship across Windows and Mac as well. So what are the next steps for FDP? So we want to create TypeScript definitions. We already have them internally, but they're not versioned. But we're going to expose them. There are other efforts by third-party developers who actually wrote them and provided them, which is pretty awesome. We want to implement app step debugging based on the protocol that Chrome lets you debug things, or Node.js. And we also want to provide JS memory profiling, which is something we already have, but we have to expose it in a prettier way, because if we're just gonna send a JSON object, it's not going to provide you a lot of value. So the future. So we want to complete across Fitbit the move to GCP. We already have started the work on Fitbit developer platform. For the team that I am in, we have actually finished. This is not there's nobody from the other teams here, so I'm not kind of poking them in any way. We also want to use FDP to build our future apps, and not necessarily just apps. We want to write every effort that is front-facing based on the same principles, especially the developer bridge, which is very agnostic in the way the protocol is implemented. And we feel like these will help us improve the shipment of our products and will help us better understand the quality of our products. And now the last part, which is a short demo, which I think we have time for. So we're gonna do a fetch and just use the URL for our API and the headers. Wait a sync. So we also have to include our auth token, which we'll get in a second. Authorization, right. And then just return response.json. Awesome. So that should mostly do it. Apart, I have to remember to get back to the auth token part. And now let's kind of send it to the device. So we're just going to use the sockets implementation. So this is kind of how our APIs look like. They look like normal NPM packages, right, or modules. So let's set a timeout so we actually get to see the change. And do something like right 1000 and get user promise dot then and use messaging dot peer dot send, and we're going to send the name only and have something like user profile. Believe me, I know this by heart. User dot full name. That's kind of the gist of the companion code. And let's go to the app that runs on the mobile, on the device, sorry. So import although this has the same name as the companion part, these are totally two different packages. And the way we have this set up, we have typings defined for different typings defined for both of them. So let's go and listen for the event. Event. Message event, I think. Right, and we're just gonna display it on screen. So as I kind of mentioned earlier, we try to write our APIs in a very familiar manner. So we're just gonna do document.getElementById, which is like you'd expect in HTML. And get some ID dot text equals event dot data dot I think name. Right. So we have this set up, and let's make it at least fit on screen. And we can do that, but by having something like text ID some ID something slash text. Right. And let's update the CSS as well. By the way, this is not the CSS that you might expect. It has some common things, but it also has some proprietary properties, so it won't match one-on-one to the CSS you expect. Right. So the only thing that I think that we have to do now is just get the auth token and hope that it works. So let's go to fitbit.com. Which is working, yay. So we're just going to grab the OAuth. By the way, this is a demo account, so you can steal it if you want. I don't care. So we placed it here. And let's see what we have to do now. So we're just going to run the Fitbit CLI. Huh? Oh, sorry. And as you see, I've logged earlier in my test account, so it knows who I am. So now I'm just going to do build, which hopefully would build. So it worked. And now I'm going to do install. So this is not going to work because there are no devices connected right now. So what I'm going to do is just start the simulator. Oh, right. So that didn't work, so we're just going to have to start a simulator. And so as you can see right now, we have the simulator connected to the developer bridge, so it's also on the same persona. This is, you can't see the email, but trust me, it is. So we're going to do an install. It found the Versa simulator. And now, hopefully, it will work. So something, oh, and it changed, so it worked. This is the name I had, so it's incredible that it worked. Awesome. So that was our presentation. If you have any questions, we're available. Yeah?
How did you implement the automation testing for to test your app, your device? How did you implement the automation testing? Do you have some continuous integration process?
The automated, hello? The automated testing for what? Sorry, I didn't understand.
To test your devices and
Oh, well, that's a good question. We don't have a lot of things in that area. We do provide some manual tests. So let me kind of explain a bit where we at. Where are we at? So the thing is that the rendering part that we're displaying is kind of proprietary. So we need something that will let us access things from the DOM to let us actually automate a lot of things, which we don't have right now. But we are working on that, and that's going to help us further down the line test both the simulator and the device itself. That's kind of something. Any other questions? Okay.
So for any other questions or anything else, or if you want to learn more about what we do, either at Fitbit in general or in our office in Romania, please come find us at the booth on the somewhere side over there. Thank you.